Afternoon, everybody. Great to be here. So, as you know already now, I am Matt, and I am from New Zealand. It's a small country a long way away. I'm lucky enough to both live and work there, which means I work remotely. So it's doubly exciting for me to be here, getting a lot of FaceTime with everybody today. But surprisingly, given that, this is actually only my second SREcon and first time speaking, so thanks to Betsy and the program committee and everybody else for having me. Hope you enjoy it. At Google I work on the customer reliability engineering team. I work as the tech lead on that team. And hopefully some of you caught Dave's talk yesterday, an update on what we've been doing over the last year, and what I have here is a link to actually the video from Dave's talk last year, because obviously this year's videos are not available yet. You can have a watch of that afterwards if you're curious about what CRE is. But very briefly, CRE does SRE with Google's cloud customers. And one of the ways we do that is a shared reliability review. We sit down and we go through the application and we decide, what are the risks, what are the threats to the reliability of that application. And in doing that, we end up with a list. And so that's a situation that I have experienced, several times throughout my career, is I'm on a team, I'm looking after a system, we have an application, we have a set of risks. How do we prioritize that, and how do we communicate that? And so that's what I want to share with you today. A little bit about what risk is, my observations on it, approaches to it, why we need to prioritize it, and then we'll do a little bit of a story about how CRE went through that process, how we approached it, and how we came to learn that there's actually a whole field that specializes in this called risk management. And that's really the end point of what I want to share with you today, is about how we have started to adopt some techniques from that field of risk management into what we're doing, and how I think we, as SREs, as a profession, actually have a lot that we can learn from risk management. Now, on that note, is anybody here, would they say you're formally trained in risk management or have a lot of experience with the field of risk management? A couple of people? Great. So I apologize in advance if I get this horribly wrong and make you cringe. I am a very enthusiastic learner in this space, but I have no formal training in risk management. So I hope to share some useful things with you all, but I'm really looking forward to feedback at the end of this if I stuff it all up. So let's dig straight into it. Let's make sure we all understand, what are we talking about when we talk about risk. All right, and so if we look at the dictionary, I think the definition that the dictionary is going to give us is that risk is a situation involving exposure to danger. This is great. It's a nice intuitive definition. I think we could all agree with it. But it's also very vague. We need some context to help us understand this. And so I put it to you that as SREs, our context for understanding risk is the SLO. SLO, as we've heard over several talks already at the conference over the last couple of days, is critical to what we do as SREs. And so to get an SLO, you start with an SLI, an indicator, a quantifiable metric that tells you something about some aspect of your service that's important to your users. And then you set a threshold for it, you set an objective, and that SLO is how you manage your service. Once you've got the SLO, the inverse of that, 1 minus the SLO, is the error budget. And actually that's often a lot easier for us to reason about. This is the set of things that we can allow to go wrong and still have our users be happy. And so understanding these concepts gives us the way to frame risk as I'm going to talk about it today. And so that risk that we are talking about is a situation involving consumption of your error budget. So let's dig into that a little bit more, and let's go into it. And start with a little anecdote. I was talking to my mother last week and telling her that I'm flying away from New Zealand, I'm going to this conference, I'm going to the US. She's interested, she's like, what are you talking on? So I send her the link. She's like, oh great, you're at 2 o'clock in the afternoon on the last day of the conference. That's the sleeping slot. Everyone's going to have their head down on the desk. And I'm like, thanks mum, that's really encouraging. But it's all right. That's a risk I have here, and so we can deal with that. So we're going to do a little bit of an exercise now. So if you had your head down, wake up. It's time to do some thinking. What I want you to do is, what is the biggest risk facing your application? If you don't run an application in production, just imagine, if you were running an application, what's gonna keep you awake at night, or what's gonna keep you awake at 2 o'clock in the afternoon listening to my talk? All right, and so for many of you, let's just do a show of hands. Who thought of like a disaster, some sort of scenario like a data center going down, hurricane, fire, flood, some sort of disaster? Great, so a few hands I see. Who thought of, I don't know, a software bug, a configuration error, some sort of very technical problem that makes the system not work as it's intended? Great, more hands. Now, what about somebody may have thought of a process? Your testing is not good as it should be. You roll out configuration changes globally all at once. Anybody wanting to own up to that? Yeah, a few more hands, great. And then maybe somebody else will put their hand up and say, I thought of something completely different that doesn't fit into any of those categories that I've just explained. And so the first observation that I have about risk is that risk comes in many flavors. It's very hard to box or describe with a single set of definitions. There's many shapes, many sizes, and if we went around the room and actually talked to everybody, we would find that there's just too much to sum up in any particular way. The second observation I have is that even though there is a lot of risk is also a very personal thing. When we start thinking about risk, it's hard for us to talk about it without that entire conversation being shaped by our previous life experiences and the history that we have in that particular situation or in other situations that we think is comparable. And the example that I have of this, what really brings this home to me is bees and wasps. Now these are, objectively fairly good things for the world. They give us honey, they pollinate flowers, but I happen to be allergic to their stings, and so, they're risky things for me. And so, if a bee came and landed on this lectern right now, I would potentially perceive a lot more risk than, another one of you sitting here. And so I think there's two interesting things about this. One is that, there's a factual aspect to this. My personal situation means that I have an elevated sense of risk from that thing than another one of you. And you can relate that back to applications that you're running in production. The set of risks faced by an application, doing financial transactions involved with money is going to be very different from the set of risks that you're concerned about for a mobile game or a free website. There's different categories of risks. And so that's the factual side of risk being a personal thing. But then there's also the perceptual side of it, which is, I am influenced by those past experiences, being stung in the past, knowing that my body turns into a balloon and various unpleasant things like that. And so that can cause me to be hyper aware of the risk of a bee or a wasp sting, potentially to the exclusion of other risks that in reality are bigger to me, and so I'm blind to them. And so these two different personal aspects of risk, play out. And I think the question that I would ask you also is, think back to that risk that I had you consider a minute ago. How confident are you that your assessment of that biggest risk for your application is the same as your colleagues, or the same as your managers, or the same as a supplier or somebody else who you are wanting to get to do something about that risk? And so that's really the motivational question for the how to communicate and prioritize risk part of this talk. So we're going to really dig into that. But the third observation I want to make is it's not all bad, right? Like risk, we can very easily get into this mode of talking about risk as if it's something that's always negative. But risk is also how we make progress. Without risk, no reward, common phrase that many of you may have heard. And so we need to realize that as well, and we need to come to an acceptance of the fact that risk can be good. I've been teaching my son to ride a bike recently. This is not him, this is just a generic photo. But teaching somebody to ride a bike is a process that illustrates that very clearly. If you don't take the risk of taking off the training wheels and getting started on two wheels, you're never going to get the pleasure and the fun of riding a bike. But you have to be willing to take that step. This talk is not about appetites to risk, but I think there's also a lot that you could take from that analogy. I actually have a couple of sons, and they've got the same genes, the same upbringing, but they have very different approaches to how willing they are to take that risk. So it's a whole other aspect, but that's fascinating as well. The thing to take away is that out of that set of risks that we have, Clearly there's some that we say are acceptable and we want to take, and then there's others that are unacceptable and some in the middle. So we're going to need a process to help us filter, and we're going to need a way to deal with this. So one approach is to ignore it. And I'm sure plenty of us can identify with being guilty of this at one time or another. We develop a bit of code, we deploy an application, and it's just a throwaway at the moment. We don't need to do all of that proper part of our job to make it reliable. It'll never be important. It'll be replaced next week. So let's not worry about risk. Let's just put it out there in production, and it'll be fine. But circumstances change, and it becomes more important, and it's easier just to keep thinking, it'll be fine. I'll get lucky. But if you're standing on the beach and the wave is coming, it's going to get you, regardless of whether you're looking for it or not. And so ignorance is not bliss in this scenario. You cannot ignore risk. But on the other hand, going to the other extreme and being paranoid about risk doesn't help much either. I think the common way that I see this manifesting is trying to isolate our services, or just trying to be so safe that we feel like there is no risk that's threatening us. We say that change is often what introduces risk to our services, and so we could have the default instinct to not change frequently, to try and get things to a stable state and then just leave it there. But the world is changing around us, even if we try and keep our service still. So that entropy is constantly going to be introducing new risks to our services, whether we are fighting them or not. It's counterintuitive, but I'm sure many of you can also identify it. Like when I start with a customer and they have a weekly release versus starting with another customer and they have a monthly or a quarterly release, I can almost predict that we're going to find less risks in the system that's releasing weekly than the system that is releasing quarterly. So we need to find an approach that is somewhere between these two extremes. We need to find a way to engage with the risks and decide what to do with each one of them on an individual level. Because both of those risks were very much about, both of those approaches, were very much about either ignoring all risk or just trying to isolate ourselves from all risk. And so when we talk about engaging with risk, there's sort of three general approaches that you bucket it into. You can try and eliminate a risk, make it so it doesn't exist at all. You can try and reduce it, manage the impact in some way. Or you can try and avoid it. It's still there, but it's far, far less likely to actually impact you. But there's many risks, and trying to decide, there's no general approach that you can't do these for all the risks. And so trying to decide which of these tactics to take for each risk actually takes a lot of work, let alone then when you go and have to implement it, if that requires a rewrite or a reconfiguration of your system. And so this is the motivating point that brings us to the conclusion that we need a way to prioritize risk. So I want to make another observation here about the industry as a whole. And so this is drawn from my own personal experiences, but also what I have observed in other companies and going to other industry conferences like this. And that is that the fundamental way, the most common way that we deal with risk as a profession today is through intuition. We often try and dress it up and say that it's experience or judgment. But fundamentally, when you peel back the covers and you look behind the scenes at what we're doing, it's based on intuition, or it's based on gut feeling. It's based on an evaluation of this thing is worse than this thing. There's no systematic process that is driving it. And I didn't see the talk that was next door just before, but on the tweet stream that was coming past, I think it would have been very interesting to me, because I think one of the things that I am starting to become more aware of, and I think many of us are starting to become more aware of, is that psychology has a lot to say about how terrible our brains are at intuitively prioritizing these sort of complex risks. Our brain is not too bad at keeping us alive. There's a level of intuition that works very well for a set of physical risks and things that actually harm us. But what we're talking about here are complex system risks. And there's all sorts of biases that even if we are aware of them and even if we're trying to avoid them, it's very hard to break out of that. So a few examples. I don't claim to be a psychologist, but this is things that I've learnt over time, is we're more likely to recall and put weight on things that have happened recently. The outage that happened last week is going to seem far more prominent and far more risky than the outage that happened 2 years ago. We're more likely to perceive risk from things that are novel, the disaster scenario, the really interesting, convoluted bug that goes through several phases to make it into production versus the simple typo. And then our mood and our environmental factors can also play into this and influence our assessments at any particular point in time. There's a story about a study that was done on an Israeli parole board made up of judges who were considering parole applications. And so what this study looked at was whether there was an identifiable statistical correlation between when in the session the parole application was considered and the likelihood that it would be granted or not. And so it controlled for variables like length of sentence and type of crime. And what it found was that your parole was far more likely to be granted if your application was the first one to be heard in a session rather than the last one, before lunch or before the end of the day. And that's a study of a group of, judges who are professional people for making decisions and applying good judgment. And so to me, that really hammers home that point that even when we know about these things, if we're trying to do it intuitively, judgment based, in our brains, then we're going to have problems. And so what we need here is a system. This is a pretty common technique in the SRE landscape for when we have a problem that we can't solve with humans. We put a system in place, something that forces us to go through a process that takes it outside the realm of purely our brains and makes it visible, makes it open to peer review, makes it open to feedback. And this is both useful for the prioritization step in and of itself, but it also allows us to break it down into a little bit more detail so that we can start to expose some of the biases that might be coloring how we came to those evaluations. So all of this is background. I'd sort of come to a realization over a lot of this over my career, and as we went into CRE and as we designed what we did with customers, we knew we were going to be doing these risk assessments, we knew we were going to be having a big list of risks, and we knew we were going to need to prioritize them and communicate them in some way. And so we were it was fairly obvious to us that we were going to need a system of some sort. But we didn't yet know of any good systems that existed to do this, and so we went about trying to create one ourselves. And so I want to tell you about our first approach to doing that, which is the risk matrix. So in sitting down and having those conversations between ourselves and with customers and trying to really answer the question about, how would we deal with risk in a more systemic way? How would we try and break it down into its component parts so that we can compare to what might be very different risks to each other? We came to an understanding quickly that it's very intuitive for a lot of people, and it's very helpful to take a risk and characterize it in terms of two dimensions of likelihood and impact. So likelihood, you can also call it the probability. It's what's the chance of this thing happening? What's the chance of a bee flying in here right now and stinging me on my arm? Pretty low, hopefully. And then impact, what's going to happen if that risk does actually happen? How long is your application going to be down for? How many queries are you going to lose? And so we started trying to take that big list of risks that we had and classify them and categorize them in terms of these two categories. And we did it by assigning 3 levels, sort of small, medium, and large. And we gave them names that were a little bit more meaningful in the context of each characteristic. So you have frequent, common, and rare for the likelihood, and catastrophic, damaging, and minimal for the impact. So 2 categories, 3 levels each. A pretty obvious display of this is as a matrix. And so we made this, and we put risks into it. And about this point, this was when we started to become aware that actually the problem we were solving is not really novel to us. There's a whole field out there, and the risk matrix, many of you may have seen it before. It is actually a fairly common method of presenting this sort of information. And so what we found is that it is useful as a communications tool putting a risk matrix in a report rather than a big list of textual risks really does make it easier for people to comprehend the list. But when we tried to use it for that second purpose, for prioritization, we started to see a few problems with it. And they basically came down to, like, the example matrix that I have here, I've put text in all of the boxes. Don't bother reading it. They're just examples. I'll post the slides later if you're actually interested in the examples. But while I've put an example in every box there, when we started to use this in reality against real systems, we found that the bucketing was very inconsistent. It was very uncommon for us to identify a risk that we would say is catastrophic and frequent, because people tend to do a pretty good job of keeping those risks out of their systems. And likewise, it was hard for us to categorize risks as rare and minimally damaging. Whether this is because it's probably a failure of imagination. It suggests that maybe we're not eliminating as much bias as we thought. Maybe we are not going wide enough in our search of risks. But the problem was everything was clumped into a set of boxes that tended to be around the middle. And now, so when you come to try and prioritize from this, naively you can assign an ordering across the boxes. So you could start with the frequent catastrophic things and then go down to the frequent damaging things and across. And that kind of works on the face of it until you get to a situation where perhaps you have one common catastrophic risk that you've identified, but you've got 10 frequent damaging risks in the other box. And now do you really want to fix that common catastrophic risk first, or is it more beneficial for you to go and fix those 10 frequent damaging risks, or maybe even half of them? And so you get into this situation where you can't actually define an ordering over the list, over the matrix that works generally. You're into the situation now where you have to have an ordering over the matrix that is not only specific to each instance of the matrix, but also the particular risks that's in there. And we just didn't have enough detail for that, and then the clumping of things together in a small number of boxes made that even worse. We'd really just transferred the problem. So the clear signal at this point was, we should stop trying to do this on our own, and we should go out and look around the world a little bit. And risk is not unique to us. Plenty of other people in the world have had to solve this problem before. So we went and did some reading, and stumbled across the field of risk management proper. And so it might be obvious to many of you, but I had never actually realized that there was an entire field and academic study that was dedicated to this. And this was a revelation to me. This was amazing. Set off a chain of some really interesting reading. And so one of the techniques that I learnt about is called expected cost. And this is quite commonly used in the construction sector, the oil and gas sector. And what it does is it basically takes the likelihood and the impact and it quantifies them, and then it multiplies them together. And that's it. That gives you your expected cost. Impact times probability gives you the expected cost. And because you've quantified it, that cost is expressed numerically, and so now it's very easy to sort. And so this sounds great. This sounds like an approach we can use if we can work out how we can quantify those risks that we'd previously just been putting into coarse buckets with some numbers so that we can apply this formula to it. Now, one sidebar here is that cost. Everybody else who does this works in terms of dollar costs, and dollar costs are important. Like at the end of the day, most of us are in businesses where we are trying to make money, and so the revenue is important. Or where money, it's pretty hard to avoid money. So even if your primary purpose is not to make money, there's probably some financial aspect that your service is coming back to. Fact of life. Sorry. But as SREs on a day-to-day basis, I'm not sure that money or financial cost is the most useful thing we can use here. Often it's very hard to understand the relationship between a particular outage and the financial cost that it generates. Even take the most obvious example where you're a retail store or something, and so you're selling, and so you've got a revenue rate, and if you have an outage, you can calculate how much revenue was missed during that outage. What I've typically seen is that you then have a spike in revenue after the outage because the users come back and they retry. And so if you're purely calculating the cost in terms of the revenue lost, then that might underestimate the actual damage to your users. And then in other scenarios where you don't even have a revenue rate that's readily available, or you're giving something away, you're giving value to your users. I don't know, do they pay you when you have an outage? I've never found anybody who can make that business model work. So what becomes apparent here is, like we talked about the error budget before. And so we have something we call a budget, and we have something that we're trying to deal with that we're calling a cost. And they're not in the same units at the moment, but we should be able to put them in the same units. That seems like a problem we could solve. And now we have a nice model that we can use to prioritize and categorize those risks. And so let's talk about expected cost for SRE. So likelihood, MTBF. Has anybody here never heard the term MTBF before? One person. 2 people, 3 people. Okay, some people have. Great. I don't know why I asked that question, because of course somebody hasn't going to heard of it. But I think the MTBF is a fairly commonly used measure in the industry, and it's the mean time between failure. It's a way of quantifying the likelihood of a problem occurring. And so we can use this number, or in an ideal world, we would use this number. We would have a repository of data collected within our organization that said how frequently this risk had occurred in the past, or maybe even across the industry, how frequently this type of risk had occurred in the past. Sadly, nobody I know actually has great granular data for those types of MTBF figures that we can use for this. Even at Google, where we keep pretty detailed statistics about our incidents and our incident response, I haven't found any figures that are really granular enough to do this. So what we tend to actually end up doing is working with estimated figures for this, and so I call it ETBF, estimated time between failure, because it's not actually a statistical mean. Similarly, for impact, we can quantify that in the mean time to resolution, or again, the estimated time to resolution. And so depending on your SLO, the unit of this is going to differ, but many SLOs we talk about minutes and we talk about time, and so that's what I'm going to use for the rest of this talk. But if your SLO is quantified in number of requests, then you could equally, instead of I still say estimated time to resolution, but you could be estimated requests to resolution. It just needs to be a measure of how much damage will occur until that risk is fixed. And this is also where we have the opportunity to break into a little bit more detail. And so rather than just putting a single number there for the estimated time to resolution, we can break it out into the time to detection, the time to resolution, and the percentage of users that are impacted, because often we're dealing with sharded or replicated systems where a risk is not going to affect everybody at once. And so once we've done those estimations, we can multiply them together and we get the annual error budget impact, which is a number which we can now rank. So let's look at an example of that. And so we have a spreadsheet which we use for this with customers. You can get it at that link there or at the QR code. You're welcome to follow along now, but spreadsheets kind of suck to present like this, and so I'm also going to give you like a cut down version of it on the slides. So let's start with Let's start with a list of risks. Those of you familiar with risk management might understand this as a risk catalog, simply taking every risk that we're aware of and writing it down. And so, here we have an operator accidentally deletes databases and you've got to restore from backup. Bug in a new release breaks an uncommon request type. Physical failure of the hosting, you've got to implement a DR or a backup plan. Overload causes 15% of requests to be too slow during your peak hour each day. Or you've got no lame ducking on your load balancer backends, and so every time you restart them, you lose queries in flight. So as I've read those out, you've probably formed in your head already a loose stack rank of what you intuitively think those risks, which one is biggest. But so now we can go through and we can actually apply numbers to them. And so we can say that, if we accidentally delete the database, we're probably going to detect that pretty quickly because everything's going to stop working. But it might take us, 8 hours to restore because disks are slow. It's going to affect all of our users, but hopefully it doesn't happen very often. So the time between failure is, a good number of years. Then similarly, a bug in a new release, well, it might be very slow to detect because, it's an uncommon feature. We weren't actually monitoring that feature. But relatively quick to roll back once we get there, fix a small proportion of users, and depending on how our testing is, it might actually happen relatively frequently. And so we can go through and we can fill that out for all of the risks, and then the spreadsheet's going to calculate for us that expected cost. And then we can, if you're in the spreadsheet, you can flick across to the sheet called stack rank. And what we can do is we can sort that list by that stack rank. And we've achieved our prioritization. And we've achieved it in a fairly objective way by going through, estimating those quantities. We now have something that we can not only use as a prioritization tool, but we can use as a communication tool. Because it's not just me saying, I think this is the worst risk anymore. It's me saying, I know this is the worst risk, because we've prioritized it. And if we disagree, now we can go back to the source data and we can actually talk about, will it take 30 minutes to resolve or will it take 5 minutes to detect? And those are things that we can actually test, through our, weekly, wheel of misfortune or our chaos testing, our game days. And so I think just this in and of itself is a huge benefit to us as SREs when we're going through this process. I don't recommend that you use the stack rank as your primary engineering prioritization tool. Like, don't go and put this into your backlog as is. This is intended as a tool for you to then merge with the rest of your business requirements. What this is telling you is the impact of risks, and now you then need to bring that together with the rest of your business data to decide, are fixing these risks, more important than delivering a feature? And that's really the intended use case of that. And so to help with that, we have a few more columns on the spreadsheet that let you play with this stack rank of risks in terms of specific error budgets. And so at the top of the column, you can put in an SLO that you might be deciding to target, such as 4 nines. 99.99%. And that gives you a 52, 53-minute error budget per year. Now, when you're trying to manage an error budget, I said I wasn't going to talk a lot about risk appetite today, but you're going to have to make a judgment about how much of that budget are you willing to spend on a single risk. And for us, we come down on the side of maybe 25%. And we say anything that's going to spend more than 25% of the budget is unacceptable. Has to be fixed. You can't live with that in the system, because these are just estimates after all. And so anything that's more than 13 minutes, if you're aiming for a 4 nines budget, you've got to fix that. And so everything gets highlighted red in that column. Like if you're aiming for a 4 9 system and this is the risks you have, you've got a lot of work to do. So maybe you decide that you don't actually need that extra 9. Let's drop down to 3 nines. And so now we've got a bigger error budget and our threshold is bigger. It's 131 minutes. And our overall budget is 500 minutes. And so those bottom 3 risks, they now fit within our budget. So we can say they're acceptable. We don't have to do anything about them. And it's just those top 2 risks that really need our attention. Now, remember, this is an estimate, so don't go and take this as a quantifiable proof that your system is going to get 3 nines. That's not what this is. It's an estimated planning tool. But where this really becomes useful is if we assume that there's actually a whole lot more risks down the bottom of the sheet, which sum up to around 407 minutes in total. And so then with the bug in the release adding another 119 minutes, that's what fills our budget. And so now we have this release, accidentally deleting database risk in the middle, which we've colored orange. What that means is that risk in and of itself is not unacceptable. It's not spending more than 25% of your budget, but it doesn't fit within the budget. So you're going to have to fix it. But let's say you trust yourself and you're like, I'm not going to delete my database. So I don't really need to do anything to fix that risk. I'm going to accept it. The spreadsheet actually allows you to put something in that column, and that column will turn blue to say that you've accepted that into your budget. And what's going to happen is the yellow is going to move down to the next couple of risks, because it's going to say, okay, so if you want to live with the risk that you might delete your database, now you've got to fix that bug that something in a new release breaks an uncommon request type. And so it allows you to interactively play with the set of risks in your error budget. And so that's another very useful planning tool that you can take back, to the rest of the stakeholders, to your dev partners, to the business that's driving your feature requirements. And you can use it to say, here's the work we've got to do if we're serious about hitting this SLO versus, here's the features that you might want us to implement. So summing up, here's the takeaways that I want you to get from this talk today. First of all, you need an SLO. If you don't have an SLO, life is going to be very hard as an SRE. It's the bedrock that all of our decision making comes from. But unfortunately, once you set an SLO, you're going to discover that the world's a terrible place, and it's full of risks that are trying to make your life a misery. And so you need to prioritize those risks, because you don't have infinite time and you have other demands than reliability. estimated cost is the best way that I have found to prioritize those risks without falling victim to intuition, bias, and everything in the world that is terrible and is trying to trick me. An estimated cost is very easy to use. We have the spreadsheet, which you're very welcome to take, and the entire reason it's a spreadsheet is because it's very easy to modify. But even if you don't like the spreadsheet, just that simple, the core idea here is that you take each risk and you quantify it as likelihood and impact, multiply those values together, and then stack rank that. And I think even if I could just get the entire SRE industry to believe that adopting that was the way that we approached risks, I would be a very happy man. Thank you. I don't know if I've got time for questions, but... All right, I got a nod, so if anyone has questions, I'm happy to take a couple of questions.
I'll kick you off while everyone else is thinking of questions. Are you familiar with the concept of a never event, like in medicine, like things that should just never happen? Because I think we have never events in technology as well. Like, we should never have a serious data breach, or we should never permanently lose large amounts of customers' data, that kind of thing. How do we factor those into risk prioritization? Because they may not directly affect our SLO in most cases, or if they do, like the financial cost or the SLO cost doesn't fully reflect the badness of the thing. Do we just give them a value of infinity and do whatever we can to minimize them, or?
Yeah, it's a good question. I think it's maybe the same as what I've heard of as black swans, a concept from, I think it was Nicholas Taleb. And so it's like things that are risks that just are so rare, like your brain cannot even conceive of them, and all of us sitting in this room cannot conceive of them. They just come out of nowhere and change the industry. Meltdown, perhaps.
Some of them may not be that rare, for instance, though. I mean, sometimes you do have these risks, and there's a quantifiable risk of them. It's like things like surgeons leaving stuff in a wound, right?
So if it's quantifiable, we absolutely think you should put it in here, and you should account for it. I don't claim that this is going to solve absolutely the black swan case where we can't even think of it and we can't even quantify it. And so I think that's where just resilience in general, and in solving all of these risks, hopefully you are developing techniques that make you nimble and make you resilient, which will also help when those things happen.
Hi, I'm Shane Smith. I work with DoD, and there's a variety of tools that you could also look at. Have you ever seen something called a failure modes and effects analysis, or fault tree analysis, or probability risk assessment that NASA uses? And so they're used in the nuclear industry as well. So they're all techniques for identifying a failure mode that you think is going to happen, a probability associated with it, and the impact of that failure, not only at the root level, so how can you detect it, how can you mitigate it, and so it's a formalized process that then you can get prioritized risk indexed on it, all that. So.
Yeah, I don't claim to be expert in any of those, but I have started to become aware of them, and I think the challenge we have is often many of those existing processes that we find are very heavyweight. If you're operating a nuclear power plant, that's probably justified. For the software services we're dealing with, I haven't yet found anything existing that was the right balance between effort reward, and so that's where this expected cost method really stood out to me.
Yeah, so they're very similar techniques. As a matter of fact, I am against some of the practices so you can go up to criticality analysis, which says you figure out probability of an event, a real probability, and the cost. But the formats are really what you should be looking at, because they're good record-keeping things of, okay, this is the thing that I had, this is how I'm going to mitigate it. So that's where those techniques may be of real value here.
Please phrase your questions in the form of a question. I'm sorry to be a pedant about this, but this is really important to make sure that more people get to ask questions. Thank you.
All right, so I'll come find you because I'd love to get some reading off you. Thank you.
Those of us who find humor in mathematics will remember Goldman Sachs reporting a 26 sigma event during the 2008 crash, which was obviously due to a discontinuity in the data. Do you have anything about modeling changes in the distributions of the underlying data?
Not yet, but one of the other things that I've read about and haven't had a chance to apply yet is like once you start to get into this sort of expected cost, there's a thing called a sensitivity analysis, where I probably can't do it justice to explain in the time available, but it plays with the values and it gives you a sense of the output that you've got, how sensitive is that to the input data that you put in. And so I'm very interested in experimenting a bit with that, and I see a sign that says time's over, so thank you all very much.